Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So in this video class, I am going to teach you predictive parser. So last video class I taught you types of parser, that is top down parser and bottom up parser. So this is example for which parser? Top down parser. So what is top down parser? Going to parse top to bottom, that means root node to leaf node. Clear? What is bottom up parser? From the root node, that means input to start symbol. Okay. So this is the example for top down parser, and I taught you one more parser in the previous video class. What is that? Recursive descent parser. Super. Recursive descent parser. So that recursive descent parser have one disadvantage. What is the disadvantage? Yes, it goes backtracking always. Clear? Backtracking always. Backtracking means whenever the production is not matched with that particular input string, it want to see the next production, previous production. So backtracking may happen lots of time. So that is the very drawback in a recursive descent parser. So to overcome that recursive drawback of recursive descent parser, I am going to teach you another one parser, that is called predictive parser. Predictive parser. So that means, as the name itself, we can understand predictive parser. So the parser is going to predict the particular variable from the symbol table. Okay, right. So this may called as LL of 1 parser. LL of 1 parser. L of 1 parser. It is nothing but L means left, and look ahead is 1. It scans or it look ahead one time from the symbol. That means input symbol. I mean from the table. Okay. Okay. So first one is model of the predictive parser. I told you what is the use of parsing. What is the use of parsing? It is going to convert that tokens into parse tree. Clear? So the parsing technique, that means top down parsing, right? Okay. So this is the model of predictive parser. This is the type. Based on this model only, I am going to teach you the problem in the next session. Okay, this is the model. So you have to understand this model very carefully, right? So see, the model have input and predictive parsing program or algorithm. One algorithm and stack. This is stack. Okay, stack, and another one symbol table. This is symbol table. We have a method action go to. Okay, right. So this is the main heart of this predictive parsing technique, that is algorithm. So we have some behavior. Okay, so the behavior, based on this behavior only, parser is going to work. See, this input have input symbol. So sometime they will give an input symbol to parse. So that input symbol is placed here, and dollar represent the end of the input symbol. Okay, so like this, A plus B dollar. So input is placed in the input cell, that this is the input symbol, and this is stack. You know what is stack? What is stack? First in, last out. Okay, see, first come, it saves the bottom of the stack, right? And this dollar also represent the end of the stack, bottom end of the stack. This already we studied in a data structure, right? First in, first out. What is the example for stack application? If you go cinema theater queue, if the person goes first, they will buy a ticket. This is not a stack example, this is queue example. So example, if you go some hotels, some bill method is like this. In the previous years we had seen before coming the advancement of computer, we may see the bill method like this. Did you notice? So what the manager or the bill counter, what he will do is, bill collector, he will check the bill and he will place the bill like this. So it goes here, the bill, first bill goes here, second bill, third bill, fourth, etc. It comes like here. So if you want to take the last bill, we want to remove the first bill. So first come, last out. That is the method for stack. Okay, you just remember queue and stack methodology, application methodology. Okay. So whenever it goes first, it plays like first come, last out. Okay. So in the stack we may place variables, non-terminals. Clear? In an input area we will place input symbol. In a stack area we will place non-terminal. Clear? I will ask you during while doing a problem. Where in the stack what we will place? non-terminal, non-terminal, it means variables, capital letters, okay, and input symbol is a symbol. And this algorithm, how it do work is, if the top of the stack is see here, if the top of the stack is x, that means one variable, and the input symbol is a, it represents the dollar, or end means the parser halt and exit, okay. For example, if it is f comma id, fid, if I am checking this, if it represents, or f dollar, if it is dollar means this is stack symbol, top of the stack, this is input symbol. If it is dollar means, we will conclude that this is the successfully parsing technique, successfully parsed, okay. The string is accepted and successfully parsed. I will ask you, if the scenario comes like this, behavior comes like this, one variable and the input symbol, if it is dollar means, what I told you, it is successfully completion of the parsing technique, okay. So this is the first behavior. And second behavior, if the top of the stack is a terminal, for example, if a, top of the stack is a, stack is terminal, and input symbol is also the same terminal, then what we can do is, we can pop from the stack as well as input symbol. Clear? What the first behavior I told you, top of the stack is variable and the input symbol is dollar, it means end of the parser, it successfully halt, okay. If the top of the stack is terminal, here also terminal, this is the same terminal, we have a input also, we can delete from, we can pop from the stack, as well as we can delete from the, or pop from the input symbol. This is the second scenario. Clear? Suppose if the top of the stack is one variable, for example x, stack is variable, and input symbol is any one of the different terminal, for example a. If the scenario or the behavior comes like this, if it is variable, if the input symbol is terminal, what we want to do is, we have to check into the symbol table, look up into the symbol table, okay, look up into the symbol table. Production, if suppose if it is f tends to a x b means, we have to pop to the input symbol in a reverse order, clear? I will explain you while doing a problem. You have to understand this three scenario. That is, first one is, if the top, x means top of the symbol is variable and one input symbol, it is dollar, that is parser halt successfully. Second one is, x means top of the stack is terminal and a is a different variable, a is a different terminal. What will do is, parser x moves into the next symbol of the input buffer, okay. And if x is and a is a non-terminal, if x is a variable, a is also a non-terminal, here is also a non-terminal, we have to look up into the symbol table, it looks in this matrix, and what we will do is, if suppose if it is the production is x tends to UVW means, we have to pop into the stack by pushing reverse order, WVU, okay, in this order. None of this error, okay. If the three scenario is not there, it means it is the error, clear? So in this behavior, you have to understand, top of the stack is variable and input symbol is dollar. What we can do is, we don't want to pass we don't want to pass further, because it is successfully completed, okay. And if the top of the symbol is variable and here input is a variable, non-terminal, that is variable, we want to look up into the parsing table, and based on the parsing table, we have to push that production into different reverse order, okay. That is this. And next one is, if it is a same terminal, what we want to do is, if it is the same terminal, we want to do, we want to pop from the stack, okay. Same terminal, here also we have to pop, okay. This is the behavior of the parser, okay. So next video class, I am going to teach you the example problem in the parser, okay. Thank you.